Myself and my colleague Sagar Dherai, we shall be discussing the effects of a MiFi device on the throughput of an enterprise wireless technology that is operating in the 2.4 GHz frequency band. Now before diving into the testing, let's take a look at what exactly a MiFi device is. Well, a MiFi device is nothing but a portable hotspot router which uses cellular technology in the backhaul and 802.11 technology in the front end so that host client devices can connect directly to the MiFi. Now, for the test purposes, we've taken three most frequently used and non-overlapping channels in the 2.4 GHz frequency band. That is channel 1, channel 6 and channel 11.
Hi, I'm Sagar and I'm going to run you through our setup today. We are using 4 Apple MacBook Pro laptops which serve as 2 server client pairs to test the throughput of a wireless network. We are using the Asus RT AC66U as a wireless router which supports 802.11, A, B, G, N and AC wireless technologies with 3 spatial streams. We are using the Verizon MiFi which uses the Verizon 4G cellular technology in the backend and uses 802.11, B, G and N technologies in the front end. We are operating the MiFi in the N mode of operation and in the auto channel selection mode.
We are using the JPerf utility to test the throughput of a network. This MacBook Pro acts as a server connected to the Asus router via the Ethernet backbone located outside the room, and the other MacBook Pro acts as a JPerf client connected to the Asus router. Here we have the 2 other MacBooks associated with the Verizon MiFi located in a room next to which the client associated with the Asus device is located. To simulate an enterprise-like dense deployment scenario, we conducted a survey on Heinz-Zoll first load to identify the average RSSI value on the client machine for good connectivity, which turned out to be in the range of -55 to -65 dBm. We are on the Asus router's control panel. We have set the router to operate on the 2.4 GHz frequency band. We have selected the channel bandwidth to be 20 MHz. Now for the first scenario, we set the control channel to be on channel 1. Now under the professional tab, we can adjust the TX power adjustment tab to be on 10%. This helps us to obtain an RSSI value of -60 to -65 dBm on the client machine. We now hit apply. So before we begin our testing, let's take a look at the 2.4 GHz frequency spectrum using the Metageek Chanalyzer Pro. As you can see in the density graph here that channel 11 and channel 6 is being more utilized than channel 1. Also under the utilization graph you can see the percentage of utilization of channel 11 and channel 6 is more as compared to channel 1. So we can expect the average throughput to be a bit low in channel 11 and channel 6 as compared to channel 1. So for our first test scenario, let's run the JPerf tool to test the throughput of the Asus router when it's operating on channel 1 without the presence of MiFi. We are running 4 parallel streams, and as you can see, we have received a throughput of 150 megabits per second on the client machine. Now we introduce the MiFi device in our network and run the JPerf utility on the server client pair. It is interesting to note that the MiFi device operates on channel 2 in spite of the other channels being comparatively free. Now we can observe the throughput has drastically fallen to 46 megabits per second in channel 1.
We shall now plot the average throughput in Mbps for channels 1, 6 and 11 before and after turning on the MiFi device. It is interesting to note that along the entire course of testing, the MiFi device was stuck on channel 2 of operation despite having free channels in the environment to which it could have migrated. This is evident from the Wi-Fi analyzer screenshot shown over here. Now, for each channel, blue column represents the throughput before the operation of MiFi device and orange represents the throughput after the operation of MiFi device. For channel 1, the average throughput before MiFi was 136 Mbps, which drastically dropped down to 10.85 Mbps after the operation of MiFi device. This drop was caused by the severe adjacent channel interference caused by the MiFi device operating on channel 2. Similarly for channel 6, you can see that there was a relatively small drop in throughput. This was due to the minimal interference of channel 2 on channel 6. Finally, on channel 11, the average throughput barely suffered any drop, mainly because channel 2 does not interfere with channel 11. In the next graph, we shall see the drop in performance of the ASUS access point after the operating MiFi device in terms of percentage. We calculated the percent drop by using the following formula. Now, as we can see, channel 1 suffers an extremely high amount of drop in average throughput after the operation of MiFi. The drop in throughput is a drastic 92%. Channel 6, however, suffers a drop in throughput of 13.5% and channel 11 suffers a bare minimal drop of 4.5%. We can thus conclude that MiFi devices operating on channel 2 cause a severe effect on the throughput of the wireless router when it is operating on channel 1. The interference, however, goes down considerably when the router is on channel 6 and becomes almost negligible when on channel 11.
We hope this video has been informative for you and we'd like to thank you for viewing.